Hello world, it's Sumit. So today's topic of discussion would be bias variance trade-off. So basically we're going to discuss about like what is bias, variance and the relationship between them. So which we normally call as an heart of the machine learning. So before starting, I'm going to give a brief outline of what we're going to cover up in today's session. First would be like what is bias error. Next would be variance error. Then we're going to understand the relationship between both of them to know like how we can avoid underfitting or overfitting of the model and to find an exact optimal point for the best fit of a model, which we often call as a bias variance trade-off. So let's start with this session today. So the very first topic is bias error. So bias are just simplifying assumption made by the model to make the target function easier to learn, and higher the bias it's going to lead to the underfitting of the model. And there are definitely two factors, either low bias or high bias, which control the accuracy of your model. And low bias suggests there are less assumption about the form of the target function, whereas the high variance suggests more assumption about the form of the target function. If you want to plot that in a 2D diagram, let's say I got like red dot as my predicted value, whereas the green dot as my actual values. Now to understand actually what bias is, once we want to get the predicted value, we need to draw the regression line across it. Once the regression line is drawn, we're going to know the distance between the actual value and the predicted value. So the more number of distance in our data set, the more inaccurate our model is. So basically a difference between the predicted value and the actual value is the error. And to conclude that in a very simple term, bias are basically the difference between your model expected value and the actual values. So this was about bias error. So next is to understand like what is variance error. So variance is just a variability of your model prediction, or the value which you can say as like which tells us about like the spread of our data points. And the higher the value, it's going to lead to the overfitting of the model. So variance generally going to have either low value or the high value. So lower value suggests there are lesser number of outliner or the noise is spread on our data set, whereas the higher variance suggests there are more number of outliner or the noise which is present on our data set. So whenever we are feeding something to the model to make it learn, we generally do a kind of data cleanup to remove unwanted noise or the unwanted column from our model, so that from our data set, in order to make it understand it better for, or like make it accurate for our model. So to understand that, if suppose I have a model with me which we want to train with some noisy data set with a high variance, which will going to perform very well on our training data set, whereas it will going to perform very poor on our test data set or the unseen data set. To sum up, is like variance is an error introduced in your model due to the very high complex machine learning algorithm, where the model learns from the noise and also from the training data set and perform very badly on test data set. So this was about like variance error. So once we got to know like what is bias and what is variance, let's understand the relationship between them. So if you're going to take an example of the bull eye prediction, so in this case you might see like this column detects about low variance and this says about high variance. So in case of high variance, the spread of your data is larger, and in case of low variance, spread of your data is low. And whereas in case of low bias, it's been very nearer to this centric circle, which says about like more accurate your prediction. As it gets farther from this center position, the less accurate your model is, and it gets worse and worse. So in case of low bias, it is like more nearer to this red circle, and in case of high bias, it is moving away from the center of it. So what we can understand this, so if you're going to take example of this high bias and the low variance, it always going to lead us to underfit your model, whereas with high variance and the low bias, it may lead up to overfit your model. So we need to strike a proper balance to know about like in what we can achieve low bias and low variance to achieve a proper bias trade-off for the best fit of your model. So we're going to understand in depth about this diagram in the next slide. So let's move on there. So once we got to know about like what is bias and variance, we're going to understand the relationship between them. And once we got the relationship, we're going to do a kind of a bias variance trade-off. So achieving a good predictive or the performance of your supervised machine learning algorithm is to achieve low bias and low variance. So till now we got to know about this, both are kind of indirectly proportional to each other, meaning like increase in the bias will going to decrease the variance, whereas increase in the variance will going to decrease the bias. So if you're going to take up this example, you may see like this blue line going to says about training sample, whereas red line denotes about the test sample. So once we start training our model, so both of the line goes along with each other. As long as it's going down, it is good for your model because it's learning over training sample as well as predicting it over the test sample. So after certain point, you may see like this test sample going to start deviating away from the training sample, and this training sample will continue to learn as long as your model going to have the capacity to learn about it. And after this point, it would be like kind of in a high variance and low bias, and before this point it would be high bias and low variance. So this point we need to focus on, where we need to know like we have to stop at certain point to know this is my bias variance trade-off value. So because beyond this point it will going to lead to overfitting of your model, which is going to perform very poorly on your unseen data, whereas before this point it would be lead to underfitting of your model. So this was about like bias variance trade-off. So we learned very important thing, like we need to strike a proper optimal balance between the bias and the variance to have a good accuracy of your model. So, because like underfitting may lead up to the case where the model is going to perform very poorly on your data set, whereas doing a balance, it will going to have a proper chord between actual and the predicted value, whereas with the overfitting of it, it is going to perform very poorly on the unseen data. So if you're going to take up this example, you will going to see a small child is been underfitting with the small pant, whereas this balance it will going to properly fit onto him, whereas the overfitting it would be too tight for him. So this was all about like in a pictorial way to know about like underfitting, balanced and overfitting of your model. To summarize, like what we have learned today is like first was what was bias error, then we move on to understanding the variance error, then we saw the relationship between them, and with that relationship how we can find the exact bias variance trade-off to strike a proper balance between the underfitting and overfitting of your model. So I hope you had liked my video. If you had liked my video, please do like, share and subscribe, and hit the bell notification icon for a new video update. And you can comment your feedback, what you had learned from this video. For any open question, I will do try to respond each one of you. Till then, thank you.